to die. It's about to die. Look at that. I started a... So the YouTube app has been giving me some trouble, but I started a question, a Q&A. Hello, hello, hello. Welcome, everybody. Please do say hi in the chat. Are you a student or do you have a job? I used to be a student for a long time, but now I have quite a few degrees and I'm currently not enrolled in school, but I am always a student for life, always like to learn. Ironing clothes. I see. Are you ironing clothes? Thank you for liking the live. It's been a little quiet for a couple days. I don't know if there's something going on with the app. But if you're here, please do say hi in the chat. And if you're seeing this later on as a video, please do leave a comment and let me know what this, if everything was like working okay, like is the audio, video, everything good? It's been a little strange for me, like the interface. So I appreciate your support. Can you hear me and see me all right? Okay, well, Rockstar, do you have a question since you are here? Is there a specific topic you'd like to hear on? Or should I just start something? Thank you. Thanks for confirming. Audio and video are fine. Okay. 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 You don't have a question. Okay, that's fine. I could just cover something really quickly that I have been wanting to cover and call it a night. That's totally fine. So give me 1 second, please. I am going to change the title of this really quickly. Hello, Lillian Martine or Lillian Martinez. How are you doing? How are you doing? Hi, Lillian. How are you today? I'm good. How are you? Hi. Thank you for saying hi. Thank you for being here. What's your least favorite chore? Sorry, yeah, YouTube asked me to ask that. My least favorite chore is probably the litter box, cleaning it out. My least favorite chore is washing dishes. Aw, that makes sense, Lillian. Okay, I'm looking at the live on this other thing and making sure that I clicked all the right. settings. Thank you for sharing, and thank you for thank you for liking the live. Thank you for being here. Okay, let's see. Like and subscribe, and I will pin it. I will pin it. Pin the message. Okay. All right. Well, yesterday we talked about comments. Now, I will say that I'll give a little bit of an intro about the channel. So this channel, we started off as sort of a book tubing channel, book talk channel. And we used to read books and show the kitty cats. And a lot of people liked the kitty cats, and a lot of people liked my voice. And so we started with that. And then, because my background is in physics, we also started to teach and talk about physics topics. And under that, we mainly have covered a lot of like particle physics, quantum mechanics type of things at a general level, general relativity, that type of stuff, cosmology, And sometimes we also talk about purely astronomy. Now, where astronomy is kind of different from astrophysics, cosmology, physics, all of that, is that astronomy started off as a more observational thing by looking up at the night sky and seeing the objects that are sources of light and whatnot. And the approach can be kind of different. It used to be only something that we did with visible light, which is the light in the wavelength that we can see with our eyes. And now it has really expanded on to cover many, many different types of wavelengths of light, many types of light, in other words, gamma rays, X-rays, all that stuff, as well as we can do astronomy actually with other types of particles that are not light. So we also have, therefore, introduced the topic of particle astrophysics, which is my exact background. So in my PhD, what I worked on was particle astrophysics, which is the study of astrophysics utilizing particles that are not just the traditional light, but it can be something like gamma rays, it can be something like neutrinos, it can be something like cosmic rays, and even at this point, gravitational waves, because gravitational waves directly were observed within the last decade as well. So nowadays, in this current time, day and age, we actually do something called multi-messenger astronomy, which really kind of points towards this thing that I just talked about, which is that we utilize many different types of particles, not just traditional light or visible light, but many types of light, as well as completely different other particles like neutrinos, cosmic rays, and whatnot. Where did you get your PhD from? Hello, Vinny Tiwari. Welcome to the channel. I hope you like, share, and subscribe. And I got my PhD from the Ohio State University. I got my bachelor's from NC State University, that's in North Carolina, in Raleigh. And then I went to Columbus, Ohio to get my PhD in physics as well. So all my degrees are actually in physics. I double majored in physics, chemistry, minored in math, music at NC State, but I finished just my physics degree. And so my bachelor's, master's, PhD are all in that. And the subfield I worked within, or at least the one that I got my PhD from, is the particle astrophysics. I also actually worked on some cosmology because I kind of had to switch labs a few times and whatnot. Hi, Lillian. OMG, I'm sorry, but I love your voice. Thank you. I'm also majoring in physics with a minor in chemistry. Oh, how nice. Yeah, I loved chemistry in high school. So, hello, Sathes, Sathes. I hope I'm saying that right, but hello and welcome. Viniti is saying I'm also major in physics. Love your voice. Thank you so much. Thank you for all your support. I really appreciate the comments and the interaction. That really helps me to keep on going. So I really enjoyed chemistry in high school. Like I I was kind of struggling with math, but I knew you had to like get better at it if you wanted to study physics, which is what I really wanted to study. But I was also really good in chemistry. So when I was applying to colleges, I actually couldn't decide between the two. So I applied to both physics and chemistry. But I think I actually first got into physics because I think maybe less people apply for the physics major, and the department at NC State, they were happy to have me, and I actually formed a really nice bond with a professor there who was sort of the director of undergraduate studies at that time, but then later on he became like the head of the department, and then I think now he's probably something even more important. He was really helpful to me. His name is Dr. John Blondin. He works at NC State. If you are ever considering going there, you can reach out to him. I'm sure he'll give you some help. But he was really helpful to me because I was applying from all the way in India and had never been to the US before I landed here for college. So as an 18-year-old. So I used to email with him a lot on the daily, actually. I used to email Dr. Blondin. In fact, I used to call him John at the time because I thought that you just had to call everybody by their first name in the US, and I was trying to fit in or something. So I used to call him John. Hello, I am here from India, I'm coming from India. This is Oindri, and I want to major in physics, chemistry, math, and music. Could you please help me and tell me which classes I can take, and can I skip calculus? Because I already took that. And can I not take a foreign language because I already know like four. They were all Indian languages, but he actually kind of called me out. He was like, well, the Indian languages are not a foreign language for you, so you should probably take a foreign language here. Ultimately, I think that is something I got away with, but John Blondin and my academic advisor, Dr. Reynolds, they did not let me cut too many corners, and they, I think, understood where my ambitions and passions lay and did their best to help me. Wait, are you from India? Yes, I am from India. Originally, I did grow up in Kolkata in India, eastern part. East side, the coast, east coast. What all languages do you speak? Bengali, because I'm Bengali. Hindi, Urdu, English. I understand Punjabi, Gujarati as well. Little bit, probably Marathi. Like a lot of the North Indian languages, I probably could understand it, but because I did have multicultural, neighbors. Coming from Kolkata, which is a big city in India, you can get the hang of a lot of languages. I cannot read Urdu, so probably should say that the caveat with Urdu is I can understand it and probably like pretty much get it fluently, but I cannot read in Urdu because it's a completely different script. So no, I cannot read in Urdu. Hakka meti ur ter. Hello. Well, then it's pretty much Hindi only. Okay. There are different words in Urdu. I guess, sure. The script, you mean, is very important to understand in order to get it. That makes sense. Any other questions? Well, pure Hindi is not Urdu. Urdu has like whole words that are not really Hindi words. Vajinan. I don't know what that means, but hello, Hakka Meti. How are you doing? I try to read the chat you sent. It's hiding it, and the origin is the same. So I am not debating this at all. I accept completely that, but the Urdu is mixed of Persian and Hindi, so definitely very much overlapping. Hindi is from Sanskrit. Urdu is Persian and Hindi mixture. So sorry. I was looking at the other You want to become we don't yeah. I don't disagree. You want to become a researcher or professor or something. I would say yeah, or something. When I first started undergraduate in the US and really loved doing research and whatnot, um, sorry, one second. I have to do something about my hair here because it's getting very tangled up. So I'll chat with you guys while I do that. So when I first started undergraduate, I actually realized that I liked working in a lab and I liked working in research. Um, that's their food falling automatically. I really enjoy doing research. So I actually remember that. So this is for anybody who is considering college in the US or considering any kind of research position. I realized that I really wanted to do that, like work in a lab, like work on some kind of research project, which would be like my own independent research and work in a lab. Now, in college, as you probably know, there's a lot of coursework, there's a lot of classes, so it's difficult to find the time to do research, especially kind of like full time or on a regular basis. Most people end up working just the summers in some kind of research position if they are pursuing any research at all in undergrad. But I kind of had to, like, I was very driven to do research, and that was actually why I came. One of the big reasons why I came to the U.S. because I didn't just want to do classroom studying. I'm the type of person who like has to really get into something and really get involved with something in order for me to like really absorb the information and really like learn. I can't always learn when I'm just hearing it as a lecture in a classroom. And see, like when I explain physics, for example, to you guys, when I talk about it again and again and again, it really helps me with understanding it as well. So I also enjoy teaching later on. But um, but yeah, so I actually worked in undergraduate research pretty much my entire time in college. And then I went to grad school, and I, of course, there the research is the main focus on top of the coursework and the teaching and everything like that. And so, yes, at that point, I probably did think that I would become a professor at like an R1 academic, school or something, where I would have my own research lab, etc., etc. But then I ended up in a more not directly academic career, but like sort of an alternate to the academic career after my grad school. So, but yeah, when I first was getting into academics, I probably did think I would become a professor. And I did and still do love doing research, like the sort of the fundamentals of like applying yourself in a researchy kind of way is something I do resonate with even now. Rockstar is saying, I am an idiot. I buy real estate or flip or rent. Well, that's not a bad thing to do. I mean, that is, I know people who do that. And I think that's actually quite smart. The one thing why I left physics. What is the one thing? We should not drag this any further. The one thing why I left physics. What is one thing that why you left physics? It's a small crowd today, so I'm thinking that I'll just chat with everybody for a few minutes and call it a night, and do my extended studying and teaching another night. Let everybody go to bed. How was your life outside physics in college? Outside physics. Well, outside physics, I worked in a chemistry lab for the longest time. I had my own independent research project in an analytical chemistry and electrochemistry lab. It was not in a basement, thank goodness. It was actually on the fourth floor of a building. The building was called Cox Hall, Cox Hall. And wow, now I'm really remembering my NC State days. And I used to work there evenings. Uh, I did not get paid for most of my time there, but I was very passionate about my research project, and I did get paid during the summers. So I was very into it. I wanted to own my own research project. I was very sad if I didn't own my own research project. It was not interesting enough. Like just going to class and working as a little minion of somebody, like being a tech was not enough. Like I wanted to have my own project, even when I was just starting off as like a freshman in college. So, but then I remember they do want your grades to be pretty good because research is going to be extra on top of all the classes and everything. They wanted to make sure that my grades were good and everything was good. So I did have to get good grades in like all the classes that I took, and I always exceeded the credits that were like the maximum credits. I always took more, and I had to get like special permission. So I was always sort of this, doing a lot. Um, so I didn't have much of a life really, but I did go to class. I did take music, and I took chemistry as well on top of the physics. I did not finish my chemistry degree. I just finished the physics degree with honors and everything. I figured that if I want to graduate in 4 years, I want to just finish, all the stuff with some extra. I also did a minor in math, of course, because physics itself involves a lot of math. And then, yeah, I had a lot of friends, like pretty much most of the physics majors, other physics majors were my friends. I became friends with my roommates in college, the dorm mates, the people that dorm room friends. I used to eat a lot outside of outside of physics. I remember I had so many classes, and I had symphony practice. I used to play the violin in the symphony of NC State. So I used to have this late rehearsal class, and I would run to the dining hall. I pretty much ran everywhere. This is actually something that my college buddies, college friends talk about, is that she never walked. She just always ran everywhere, and she took the longest showers, and then she started running. The only time I think I slowed down was in the shower. And then I would run to all my classes, and the dining hall would close, and so I made friends with the dining hall people, and they would still feed me even after they closed, which was very sweet. And I experienced the Southern hospitality in the North Carolinas. So that was really nice. Physics cult is real everywhere. Physics cult! Yes, I was part of the physics cult, pretty much. We had a lot of activity. We hung out. We played, what's that game? We played Murder in the Dark. Do you guys know what that is? We played Murder in the Dark. Am I saying it right? I think it's like D&D, but like with people or something. Hello, Crazy Sick Wine. Crazy is saying hello, beautiful Dre. Sorry, I'm late. Hello, we're here. It's a small crowd, so I'm just doing a little chit-chatting, and then I will sign off, and I'll have to go live some other time. But I am having some fun talking to the peoples that are here and asking questions and supporting. I do appreciate it a lot. How long have you been on OMG? 34 minutes and 34 seconds. I have been on for 34 minutes and 34 seconds. So yes, we did have a sort of a physics cult. We had the Society of Physics Students. Oh, and I completely forgot. I was very active in the Society of Physics Students, and I was the outreach coordinator, as well as an ambassador in the College of Sciences. So I also did quite a bit of outreach. I have probably been to almost every elementary school in the Raleigh area and done some kind of physics outreach. And it was really funny and good in the sense that like I got a pretty good idea what the kids enjoy. So the really little kids are the best. Like under 10, they're the best. Middle school is also okay. There are some really cute middle schoolers who are very interested. Uh, Hello, Steven. Physics isn't a purposely designed dead end because of the secrecy around UFO. How long have you been on? Steven said hi. Physics isn't a purposely designed dead end because of the secrecy. About to say that. About to say what? I'm sure you had open telescope. Yes! How do you know this? Were you a physics major? So, okay, yeah. We were such a close community in the physics department, like the undergrads and some of the grad students. But honestly, the grad students, I think, were sort of like lonesome off to themselves in their labs and whatnot. Like the undergrads, we really rocked. We really like had a lot of fun. Like, so I used to go to these elementary and middle school, high school, whatever, bunch of schools, mostly elementary schools, and do a lot of outreach. So I was the outreach coordinator of the Society of Physics Students. And I remember we even won awards. So there was a point in my life where I used to put this on my resume. Like now I don't anymore because it's been a while and there's been other things that happened since. But there was a point in my life where I used to put outreach coordinator, ambassador, all this stuff, because I used to serve in the Society of Physics Students Raleigh chapter, and we won a ton of awards for doing outreach because of how active we were. And I also worked in the physics demo room. That was another way in which I made some side pocket money, because I was already involved with the outreach and whatnot. So I became more and more involved with the physics stuff. But also, I stayed involved in my chemistry research lab, which was my longest research project. So yeah, you could say that I was kind of busy. Dude, that is literally everywhere. Who is everywhere? Physics frustrates me on many levels, certain complexities that go nowhere, usually theoretically. Yeah, so I actually like experimental physics more because of that exact reason, because theoretically, even if something is not going anywhere, experimentally you still get to do something cool and measure something and write a paper on what you found or what you didn't find. So my PhD was an experimental topic, dealing with measurements. So I don't know if theorists can really, relate to that, but I believe in experiments and measurements. So I don't have that issue of like things not going anywhere. The physics cult is everywhere. Saturn is my new favorite planet. Saturn, okay? If physics wasn't in the dead end, we would have a theory of everything, but no, we still think space and time. Were you also part of any non-academic clubs or societies? Hello, Francis. Francis, did you change your name from something? Because it's space and time crumble at Planck scale. So, the thing is, I understand the frustration with quantum mechanics and general relativity not coming together and being united with the theory of everything. But at the same time, I kind of accept that quantum mechanics is the physics of the very small, and it does a good job with that. And, general relativity, gravitation is more of a larger scale thing that describes gravitation, and I'm okay with that. It's a correction to the Newtonian mechanics, which I'm okay with that. So, but I understand the frustration with not having something that unifies these parts of physics, which are the quantum mechanics on the one side and the general relativity on the other. And indeed, we have talked about this exact issue a lot. On the channel. We have. One second, sorry. How do you think Mars is my favorite planet? Space and time crumble at Planck scale. I think you're missing a C in the Planck. Mars is my favorite planet. Steven, did you change your favorite planet? Also, are you mad at me? Why were you saying that you're going to go away? How do you think physics changed? How you think did it train your mind to be a pendulum? How do you... So are you asking how I think physics has changed my brain? Sometimes YouTube switch nicknames with account name. Oh, you're Eversore? One second. You're Eversore? I'm so confused. You're Eversore? I know Eversore. Francis is Eversore, guys. Thank you so much for being here. I love that you randomly laugh. Thank you. I've only changed my name on here once. That's true. You're going to be so famous soon. I love Mars and Pluto. So Pluto is a dwarf planet, guys. It is not considered a planet anymore. I know that some of you are older than the history of that. So I am sorry, but Pluto is a dwarf planet, not a planet. And Mars is, of course, a planet. It's the rocky planet at 1.52 astronomical units away from the sun. And we are at 1 astronomical units away from the sun. And people are thinking about going to Mars because Mars is kind of similar to Earth. It's rocky. It has similar seasons, even though the seasons are longer there, of course, because their year is longer. Each season is longer and also a bit cooler because of being farther away from the sun, but in some ways similar to Earth. But I always think it's a shame that we cannot go to Venus more easily because it is closer to us, more like Earth size, and it has an atmosphere, except unfortunately it's very poisonous atmosphere, so we can't breathe it. I've never been anywhere else, lol. I will call Pluto a planet no matter what. Well, Steven, you would be wrong and spreading misinformation if you call Pluto a planet, because it is a dwarf planet and there are other dwarf planets that we also know of. So it belongs in that category of dwarf planets, which is fine. Dwarf planets are also a category of objects. I love Earth. Me too. I will say, when I say my favorite planet, I mean other than Earth. Oh my God. I'm sorry, someone sent me a joke and it's yeah, it's a little funny. I would call Pluto a planet no matter. You would be wrong, Steven. Whew. What's the secret to looking so young for 36? Crazy sick one. You keep calling me 36, but I'm actually 35. You piece of dummy. If you're from India, you should believe / know there is something else beyond space and time. Thank you, Francis. I love Mars because of the face. Dwarf planets' life matter. It's true, dwarf planets also matter. They do matter. Crazy says, wow. Are you serious right now? Ha ha. Serious about what? The 35 thing? I'm 35. I was 34, but then I turned 35 on my birthday. So now I'm 35, I think. Stopped counting. Are you serious? You're old, you're ancient. I am ancient. We're all ancient. We come from a pre-solar nebula. A metal-rich pre-solar nebula. So indeed, we're all ancient and we should be proud. Shibar, Shibharg Yasankar Chakraborty is saying big fan India. Hello, Chakraborty, how are you? Shiba is also saying Shibargo. Oh, Shibargo. Wait, Shibargo. Shibargo. I have to get this. 1 minute, guys. Shibargo Shankar Chakraborty. Is it possible that antimatter can make concave up curve where matter makes concave up? I'm not sure what you're saying. The face of Mars, but antimatter is really not that big of a deal. We have talked about antimatter and it's okay. I'm older than the internet, says Francis. I'm going to have to buy you a cane. I thought you were 65 million years old. No, we're 4 billion years old. What do you mean? Is it possible that antimatter can make concave? Are you asking about the geometry of the universe? I'm going to ask my friend to send me a PG-13 joke so I can say it on the channel. I asked, whatever, they send me a joke, but it's not PG-13. I'm older than the Big Bang. There goes a random laugh again, probably a physics joke. Shibargo, we can talk about whatchamacall, antimatter and particle physics and the geometry of the universe at some point as for your benefit, okay? Why don't you like, share, and subscribe? Please do subscribe. So then you can come back for the matter, antimatter discussion and cosmology, okay? I am from Andromeda. Love from Andromeda. Do you think Bob Lazar was telling the truth? About what? And who is Bob Lazar? Do you know who Dr. Donald Hoffman is? If not, I suggest you look him up. Bob Lazar. Oh gosh. All right, so they're sending me a new joke because the last one was not PG-13. Era 51. He was a theoretical physicist. Okay. All right. Please do hold on for the joke to arrive. Shibargo is saying, what is your profession, ma'am? What do you think? Maybe I should link my LinkedIn on here for you guys. You can find me on LinkedIn, Shibargo, and go from there. Don't tease us. Okay. Okay, whatever joke is coming is very long, so it's taking a while. Hold on, guys. Let them finish typing the joke. And antisocial. Are you calling me antisocial? Let them finish typing the joke, and then I'll tell you guys the joke. I'm not good at jokes. Oh no, this is not. This is not a. I don't know if this is gonna be appropriate. I have a breakup with dark matter. Okay, I'll read the joke, but I don't know if this is gonna work. A bear walks into a bar, demands the barkeep serves him a drink. The barkeep says no. The bear says, serve me a drink or I'll eat that woman over there. And the barkeep still refuses, so the bear eats the woman and says again, now serve me a drink. Barkeep says, no, we don't serve customers on drugs. Bear says, drugs? I'm not on drugs. Barkeep says, yes, you are. That was the barbiturate. As in bar, B word, you ate. Did you get it? I'm not sure that this was, I asked specifically for a kid-friendly joke. I don't know if this qualifies, but I still said it. I saw them in my room, very traumatic. Are you laughing? Crazy Sick Wine is laughing. Did you find that funny? I saw a landed UFO appear out of nowhere near a small lake. I'm covering my ears. Biosphere. I saw them in my room, very traumatic. Barb. I got it. You got it? Steven got it, and Crazy Sick Wine was saying ha ha ha. Can I use your... No, absolutely not. They are my children, and you cannot use them in any experiment. Rockstar is saying not at the moment, but after. Give me timeout for one moment, please. I want to see what it's like. Okay, I can put you in timeout. Here, I'm doing it. Gold Scully, I'm gonna do it right now. I'm gonna put you in timeout. Oh, Francis already did that. Cat was also children of Schrödinger. Francis, can you untime him out? I'm guessing your friend sent another joke. No, they're asking if it passed or not. What should I say? Did you guys like that joke? Should they send more? They're asking if the joke landed or not. And I'm not sure that I did a great job of delivering it because I don't want to be in trouble. It's cold. Shibargo says, tell me. Well, Schrodinger was not a very nice guy. He was an okay guy. I liked it, but I don't do PG-13 jokes. Can't. But the 1 minute should be over soon. Oh, right. You can pick the time. So you did pick the time. Okay. Somewhat, but because you're hot, you delivered it well. I see. So it wasn't funny, but... Or no, it was funny. I was trying to be careful, so I took away from the... Oh, hi, Gold Scully. So why did you ask us to put you in timeout? Tell me what a mathematician will do if a fire takes place in a house. I don't know. You could have used which. Bar which you ate. Yes, bar which you ate. Bar which you ate. That's right. Okay, I'm gonna say it again. From now. Okay. Barkeep says no, we don't serve customers on drugs. Bear says drugs? I'm not on drugs. Barkeep says, yeah, you are. That was the bar which you ate. Great. You helped me, Steven. Thank ya. Just cause search on Google. What are you doing? What does that mean? They're saying I put them on the spot for a joke. From now on, I'll be better prepared. Yeah, I mean, if you're my friend, you should probably be prepared with your jokes that I can read out loud while I'm going live, because why not? Search the joke, what I said. I'm glad you're live again. So Crazy Sick Wine, there was a period of time when you were traveling and you missed a lot of the lives. So I did go live a lot that you also missed. So, you know, you should go and catch those old lives and leave your comments on there. No, Reese. I don't know if, I don't think Reese is here. Reese, are you here? Such a lovely smile. I fall for you over again every time I see that smile. Oh, thank you. Look at this book that I have to return to the library. Going to sleep, hoping I get abducted by aliens. See you all. See you. Good night. Swinging around. Heather spread her arms. What does he think I'll do? Escape into the wilderness? What if I was going to escape? I'd have tried that first night. So this is a romance novel that I borrowed from the library that I have to return. Free brain rot. I'm so ready to send book to the publisher soon. Going to sleep. Thank you for liking the live. What if you travel? Speed of light with respect. It wouldn't be with respect to light, but the speed of light will still be a constant if you're asking about that fact. The speed of light is a constant. in vacuum. The speed of light in vacuum is a constant, no matter what speed you're going in, even if you're very close to the speed of light. Lol SR. Okay. All right. Well, it's been lovely to see everybody. I think hopefully you liked catching up, and hopefully you liked that joke, and hopefully I'll see more of you next time. Oh, by the way, let me do one thing. So what's the plan this month? You going to any concerts, doing anything fun? I'm doing some fun things. Stay tuned. You'll see what I'm up to. Please do stay tuned to see the content of the channel, to see what fun things I get up to. There will be some, hopefully, with the thanks to the universe and thank you, God. Say mango mustard. Okay. So, let me see. I think this option is not given to me yet. I was gonna do something. Francis is #1 top fan. Thank you, Francis. #2 is user random. I think that's B. #3 is crazy sick wine. Did you guys give me likes and emoji hearts and all that stuff? Don't be shy on the lives. What do you mean? I think some people just joined. They did join. Hi, how are you? And how are you doing? And who are you? And say something live if you'd like to chat. Thank you. What is... Oh, sorry. I was pressing a button to see what that does. Wait. Okay, no. Those are all the buttons. I was gonna say, thank you. Thank you, Steven. Thank you, Shibargo. I meant come more often. Yes, I will. Thank you, thank you, thank you. I will come live more often. I think some people just joined. I will come more often. I will come. Maybe I will do a fun live, as in when I'm out and about in the wild world. Maybe I could do a fun live. And and you could see me out and about. And that could be one of the lives I do. Because remember, I used to do like walking outside lives and things like that. And I think not a lot of people would join those, but some people did, and some people really liked it. And then we used to talk about physics while being outdoors, and I used to give book recommendations while being outdoors. So I think we could do that again. You can take a live with more... You can take a live with more exciting content. Whatever you think, I'm with you. Thank you. You can give an alarm on YouTube so that we can join. So if you are subscribed, then you should be getting notified. But sometimes some people don't get notified even when they are subscribed. So I'm not 100% sure. Oh, please do subscribe, because we're now 2 subscribers away from 5278. Also, you could become a member to support the channel. I will have more member-specific content because the channel is still small. I'm still kind of open to the public. But once I have a good number of members, I will also do member-only lives. So watch out for that. And please do, I'm not saying you have to do it, but it's one way to support the channel is to become a member. Okay? That's one way to support us, and it's sort of like a monthly thing. Did you do that? I think I gifted the membership to you. Was that you who gifted memberships? There was somebody who gifted people memberships, indeed. That could have been you. I think your username might have changed since then. I don't get notified ever. Well, maybe make sure that you're subscribed and you have pressed the bell icon or something in order to get notified. There might be an extra step to get notification of when I'm live. Subscribe, and then also the bell icon. And also I try to share the live out as a post on the channel as well. But I'm sad that people don't always get notified. If I get my next disability check next week, my book being published will be done. I'll get my haircut and a shave so I can send a photo to the publisher. I'm the only member. You're not the only member anymore, Stephen. So thankfully, thanks to the universe, there are more members now. But thank you so much, Stephen, for being the first member. Stephen is the first member, but you're not the only member at this point. And I am trying to get more memberships going. Hopefully be people with from the kindness of their heart can become members, because then I really want to do some members only lives once we have a good number of that. But the public lives will help me to kind of reach more people as well. So it's sort of a balance. So far all my lives are public, but soon I will also host the member only lives, okay? Has there any membership? Can I take this? Yes, you can become a member. Yes, ma'am. You should start doing experimental physics live, exploding stuff. I don't know if I'm going to do that. I was a member a while ago. I got kicked off of YouTube. Do random member. Yes, I gifted because you said you didn't have members. Oh, thank you, Rockstar. Thank you so much. But this Mad Hatter's still here. You got kicked off of YouTube? How does that even happen? How do you, how did you manage that? How did you manage that? Let me read some comments. Eclipse Horizon said, this is the best way to remember and understand something. It's to explain it. This person has put this comment under one of my study particle astrophysics with me videos. So thank you so much, Eclipse Horizon. That is a very special moment indeed where you commented. Thank you. I will reply back to you right now. Thank you. Like and share. I have no heart of a black hole. It crashed and wouldn't let me in. Who? What crashed? It just does, my dear. In my earlier days, I'm brilliant and batshit crazy. It just crashes? Acacio has said, lovely Baji. I wish I had super chat. Well, you should have super chat. Can you not see the button for super chat? Acacio is saying lovely Baji under a video called Kitty in Love. Thank you, Acacio. I don't see Acacio here tonight. Hence crazy sick wine. Hi, Acacio. I will say thank you to Acacio as well. I'm looking at my comments now on the channel. Ooh, Shibargo has said, made a comment 12 hours ago. Can I say that antimatter can make a concave up curve as matters make concave down? Reese has asked, where ya going? Let me see. I will reply to Reese. I don't see Reese here. Grimmy is blocked, so that's why you don't see Grimmy. And Doro does not come to the, has unsubscribed, I believe, and does not come to the lives anymore, which is totally fine. People can go their separate ways. I'm gonna randomly ask Reese if he is here on the live. He might not be. As in, he probably isn't. Oh, shoot. You know what? I think he had his kid. That might be why he's not here. What's your book about, Steven? Sorry, I'm very curious now. Steven, you should tell them about your book. It's a sci-fi book. What did you tell him? I said nothing. He just, you have a wonderful hairs. Thank you, Isaac. Isaac is saying you have wonderful hairs. Oh, thank you. Big Frank said, a great teacher. Aw, thank you. Thank you, Big Frank. I think I've seen Big Frank on the lives as well, but not lately. Zon Snowing. Zon Snowing said, "Nice to see a girl talk about science. You have no idea how rare it is on the internet these days." Aww. Thank you, Zon Snowing. I will reply to her as well. I think it's a her. Happy Monday, says Heike. Heike, if you're here, happy all of the days to you. Thank you so much. He just became disinterested. Huh, typical human behavior. Yes, or he might have disagreed with me on something. Good luck, says Rockstar. Yay. I think Skeletora has made a post as well. Skeletora, whenever he joins, there's some jokes that he shares. But because he wasn't here today, I asked my friend for the jokes. But Skeletora can make a lot of physics and science related jokes. Hi Guy, thank you. I see your comments. I'm responding to some of them. There was good waves in NC Beach. Oh. That's a great question. So we can cover black holes, especially remember that in order for black holes to have a temperature, you kind of need a more quantum explanation of black holes. So the whole thing about nothing ever coming out of black holes is sort of done away with Stephen Hawking's work and black hole radiation, and the fact that black holes have a temperature. Black holes having a temperature means that some things do come out of black holes, and there are particles because of quantum mechanics reasons that do come out, okay? So it is not the case that all is lost when it goes into a black hole, you never see it. That is not the case. And also, depending on how much the black hole has eaten, a manifestation of that physically that we can observe is actually the event horizon will be bigger. So we kind of discussed this in more detail from Stephen Hawking's book, and you should definitely go back to those lives if you can. They're all on the channel under the live tab at, in the past, all posted. And we considered this a lot and discussed this a lot. So it's very interesting indeed, because you bring up a good point. Classically speaking, we say that nothing escapes a black hole. That is how we set the equation for a black hole. That is how we set and find like the Schwarzschild radius for the black hole, right? And we know, okay, that's the event horizon. If you go any farther, you'll fall into the black hole and not be able to come out. So that is the classical explanation, and it works, and it's fine, and it's completely okay to work within the realms of classical physics and classical understanding of a black hole, which takes into account general relativity but does not take into account quantum mechanics. But then if you were to kind of I don't know, the grapple with the notion. Oh, hi, Agasio. If you were to kind of resolve the notion of like black holes having a temperature, then you have to kind of go into quantum mechanics to understand how a black hole can have temperature. Because if something has a temperature, then it would do some kind of black body radiation. And if a black hole is doing some kind of radiation, Hawking radiation, right? Hawking radiation, that's the, it's named after Stephen Hawking. So if a black hole is doing that, then that would mean that some things do escape a black hole, a particle here and there, some particles do escape. And how does that happen? Well, that is explained through quantum mechanics on the uncertainty principle and particles being in particle antiparticle pairs. And sometimes one of the things can escape the black hole just because of uncertainty principle, probability reasons. Basically, quantum mechanics opens up the possibility to have probability. And probability means that there could be a little probability of something to escape now and then from a black hole. And that's how a black hole can have a temperature. So I don't know if this is what you were asking, but indeed, this is a very interesting topic to me. And we have covered this quite a bit. And I just gave you a little gist of that. And we've definitely talked about it in the past. Okay. So hopefully you can go find those episodes if you're so inclined. You can just play them all in the background if you'd like. Casio 59. Oh my gosh. Casio has joined. Casio has joined and Casio has done a super chat. Most appreciated, Casio. Thank you so very much. Is Baji climbing the wall? I don't think he is right now. Baji is currently not visible behind me. I think he's upstairs. It might be that he is more warm upstairs and more cozy upstairs. So I don't see him tonight with me. Acacio, how are you? Thank you so much for doing a super chat. Let me heart it and like it. Thank you so much, Acacio, for doing a super chat. The book title is called A Farewell to Earth. I have many questions, many of stupids, but I asked this because your current topic for live is about wormhole. Is it? Or is it in the title? Thank you so much for reading. Thanks for taking me back at school. Hello, Isaac. Of course, we can always go back to school. We're not too cool for school here. And we do study and discuss quite a bit. I eat too much sometimes. Snokomoi, hello. Hello, Snokomoi. Crazy Sick One says, wow, incredibly true. What are you saying incredibly true to? 35, I'm in awe. Seriously, whatever you do, keep doing it. 35 is not that old. Thanks to the God, thanks to universe. I hope to see in the store and on Netflix. Hello, are you talking about a movie now? Hola amigos de la cosmología y la astrofísica, late but sure. Thank you for coming, Acacio, and thank you for doing the super chat. How very exciting for us all. Wait till you read book 4. Yes, but of course, but information doesn't escape because it already crossed horizon. With AI, you could probably make the movie yourself. Who is Baji? Baji is one of my children who is a cat. Is gravity leaking to other dimensions so that it is so weak? I see. That's funny. Steven said, I see wormholes every time I work in the yard. That's kind of funny, Steven. That is slightly funny. Steven is about to become a very famous author and movie maker. And he will share the book, Is Gravity Leaking? So that's a great question. Is gravity leaking to other dimensions so that it is so weak? Well, string theory attempts to, superstring theory, I should say, supersymmetric string theory, or SUSY string theory, does try to do this grand unification of all the theories that we kind of spoke of, that it attempts to do anyways, because it is an extremely, still a very theoretical theory, as in it doesn't have much proof experimentally. It continues to be sort of a theoretical candidate for a grand unified theory. And it does not only speak of and consider extra dimensions, it actually requires extra dimensions. So maybe there are other the question you're asking, the answer is I don't know. But it could be something like that. That would be really interesting, actually. If we got a better understanding of gravitation, and if it turns out that it is something where we would actually need more dimensions to explain it, and really what superstring theory has been kind of doing is sort of along the right lines or something, that would be really interesting. So I hope that, you know, that could be maybe something. Thank you, everybody, for being here. If the universe is expanding, could it not be being attracted to something else? That's a great question. Musk said that we're about to meet extraterrestrials soon. Meet extraterrestrials, you mean? So what is your opinion about that? If the universe is expanding, could it not be attracted to something else? So that's a great point. Basically, there are various scales in the cosmos. Say in the scale of, so scale, by what do I mean? Distance, scale, right? All of that, space. In the scale of, say, our galaxy or our neighboring galaxies, the universe is not expanding. It is actually more affected by gravitation. It's only on the much larger scales where we see, and we do see that. So it's not something that we just imagine or speak of. We see it. There is evidence of expansion of the universe at very large scales beyond these types of distances, right? So on the more local scales, because we even have, for example, local cluster, our galaxy, some of the nearby galaxies and whatnot, right? In the local, and those distances are not small, right? But in that type of scale, we are more affected by gravitation. But on the larger scales, we are affected by, and we see expansion of the universe, things getting farther and farther apart. The distance between 2 points that are far apart getting more big-like, as in a faraway point getting even farther away for no other reason except for like the expansion of the universe. So we think that expansion of the universe is sort of this cosmological type of effect, and it's sort of this anti-gravitation thing. Like the gravitation is is one of the players in the universe, and the other player is dark energy or whatever this is that makes the universe expand. So I don't know if that, again, the answer is I do not know, because dark energy and the expansion of the universe is also a research topic. Exactly what the nature of dark energy and exactly what it is an ongoing research topic. First, number one research topic is dark energy. Number two, dark matter. Number three, origin of all the elements. Because there are some that we don't fully understand. So I would say it's a research topic, so I don't know for sure if it's because of some other attraction going on between something and something else. But yeah, I would tend to agree that I think somebody made a comment, expanding doesn't mean it is attracted by others. Exactly. So I would tend to agree with that, where expansion doesn't necessarily mean that it is going towards something else. It's kind of doing the opposite. Things are coming closer on a more local scale, where local is still pretty far, because even the nearest star is kind of far away, right? So everything is, you have to kind of think about these different scales. But in the local cluster or in our neighboring galaxies, we are getting closer together. Of course, exactly. Like, for example, we talked about merging with Andromeda and how the newer research is saying that we might not merge exactly because there's also the effects of the other galaxies, like the Large Magellanic Cloud, and there's other galaxies, irregular galaxies, whatnot. So what do we mean by that? Like these other galaxies, all these neighboring galaxies and whatnot, basically have a gravitational effect on each other, and that is not super simple to calculate all the time. So at one point we might have thought that there is a very big chance of us merging completely with Andromeda at some point, but now we think that actually the probability might be like 50% or something, like we might not merge, right? And that has to do with gravitational effects of other objects and other galaxies that we did not take into account in the past. And as we do more and more precision astronomy, so this has to do with our ability to measure better and the ability to take more things into account as we evolve and advance in the field, it looks like we might not, there's a chance, quite high chance, of not merging completely with Andromeda, but we are probably going to get closer or something. We all will have an effect on each other. So that is gravitation. So the attraction, gravitation, as you know, the only purely attractive force. We call it a force in the context of particle physics, but remember, in general relativity, of course, it's not considered a force. It's considered the curvature of space-time. The treatment of gravitation is the correct treatment, the accurate treatment of gravitation is, of course, general relativity. But, we colloquially call it a force when we talk about particle physics, and in general, we kind of still talk about it as a force. So I just want to make that caveat, but basically gravitation is a purely attractive force. It makes things come closer together. It makes things collapse upon its own weight, upon its own mass. Like a star will collapse ultimately under its own gravitation because it will run out of nuclear power, which was keeping it burning. So it's something that makes you get closer, and we do get closer. Even that comet has to do with gravitation. I mean, comet is very local compared to, say, the next star or the next galaxy. But even that comet, like a trans-Neptunian object, we were talking about that yesterday, a trans-Neptunian object as an object that was farther away from us than Neptune, getting flung closer to the sun enough for its parts to become subliming, as in parts of its iciness going away, sublimation-like, means that it has been affected deeply by gravitation and gotten flung, I think the flung is that word, flung towards the sun within 4 astronomical units. If it gets closer, then it will be all the icy parts of it will sublime, and it will develop that comma tail thing, and that's when we call it a comet, that behavior. So again, local scale, like in the scale of our solar system, in the scale of these comets, in the scale of the trans-Neptunian objects, in the scale of the next nearby star, in the scale of the next nearby galaxy, gravitation is the winner. Okay? Gravitation is the winner. It may be a weak force. It may be it is the weakest force in terms of being a force. But it is a very important nature of the cosmos. Once again, it's a force when we think about it in particle physics standpoint. Particle physics is also the topic that does not explain gravitation, right? So colloquially, we can call it a force, and it's the weakest one. But as for getting an accurate explanation of gravitation, that is obtained with general relativity, where it's an effect. It's sort of intrinsic nature of space-time. So you got it, right? Like massive objects will curve space-time. And it's very important. Its effects are felt, especially locally, where the local is as I described above. But we have noticed, for example, with that quasar, what was it? Q's. What was this quasar again? Is it QC 323? What was that quasar? When we first started to observe quasars, remember? I'll look it up. QC, no, what was that quasar? The first quasar that was ever discovered. Does anyone, can anyone say? Can anyone remember? Is it QC 323 or 370? Oh gosh darn it. Let me just find it really quickly. It will be under active galaxies. There we go. So quasars are a type of active galaxy. Ah, there it is. Not QC, 3C. I knew it. 3C273. So remember this quasar, 3C273. We talked about it quite a few times. It's the first, I believe it was the first quasar that we discovered. After that, we discovered many other quasars. But quasars were very confusing, remember, because they are actually very distant galaxies, and they're a whole another category of galaxies. They're called active galaxies because they have a very active galactic nucleus in the center. Like their galactic center, supermassive black hole, is so very active. Things are falling into the black hole all jet-like manner and producing lots and lots of radiation. It's all very dramatic and explosive and just very different, as in lots of energy are coming out from just the center of that thing. So even though it's actually a galaxy, it looks more like a star. It's more point-like source of light. So at first when people saw it, they thought it was a star. But then when they looked at the spectra, they were like, no, this is weird. We don't expect this type of thing from a star. And then they were like, oh my God, could this be a galaxy? And if so, the luminosity of this thing is so high, it means that it's very far away. And so at that scale, so now I'm telling you, I'm trying to ground the scale of what I'm saying now with an actual object that we do know and love, which is the 3C273 quasar thing. At that scale, the universe is expanding. The distance between us and 3C273 is going to get bigger and bigger with time because the universe is expanding. So you have to be kind of like, you have to be a bit careful with these caveats of like, when we say the universe is expanding, it's not, the space between us and the sun is not expanding. I mean, we're on an orbit that's not perfectly circular. So in that sense, of course, the distance between us and the sun changes. But it's not like 2 points that are local like that is necessarily getting bigger and bigger, because in that local scale, the universe is more dominated by gravitation. But in the larger scale, the expansion does dominate. And actually, this is very interesting because one can also ask, and one does ask, and we did kind of talk about it with our cosmology lectures and cosmology discussions, that, you know, if it's going to expand and then collapse again, or will it keep expanding so much that it could never collapse ever? Did the Dr. of Einstein brain case give you a part of his brain? Oh, thank you so much. Now you're getting out of hand. Who is getting out of hand? I think if you explain this mathematically, we do actually... Oh, thank you guys. Oh, such kind comments. She's magnificently brilliant, lovely specimen. We call Baji's mom. Oh, thank you so much. So we did actually talk about a little bit of the general relativity math. So by the way, the other thing is, if you're interested, um, who is Isaac or not Isaac? I see Isaac. I agree to what he said. Um, I agree with Isaac, or I see Isaac, but I agree to what he said. What are you talking about? Maybe she's not that bright, but you all are dumb. Well, maybe there is a probability that being smart or dumb is quite relative. And so, yes, indeed. Thanks, Rockstar. It'll be a while before you see book 5. Very nice. Okay, I was just reading your comments. Let me keep going. So, because this is really fun. So, remember, actually, that thankfully, this topic of dark energy, although it's a research topic and why the universe is expanding exactly and the intricate details of that is still sort of a mystery, and we have deployed experiments like the dark energy survey, dark energy spectroscopic instrument. Mainly they want to look at these faraway sources, because remember, again, the problem with dark energy research is that you can't just do dark energy research and get sources of light, because it's going to be really tough. You guys know, right? I mean, someone asked about the aliens and whatnot. You guys know, right, that extra or what's the word, exoplanets are really difficult because they're not exactly sources of light. So looking for objects that are not stars or some kind of source of light is very tough. Like, the farther away a thing is, and if it's not even producing any light, it's nearly impossible to see these things. We struggle, but we still do try to find these things called exoplanets, because of course the interest in finding these other planets that are not, the planets of our solar system, but planets around other stars and whatnot. And that's a whole other topic that we have also actually covered. But basically, this is to say that we if we could somehow magically see all kinds of objects, that would be, we would. But more often than not, the farther away things are, it's really the sources of light that we would see, right? Whether that's a star, a binary of stars, a galaxy, or like a black hole that is somehow bright because there's a lot of stuff falling into it, and really the radiation from the stuff falling into it is making it bright and giving it away. Those types of things, right? Sources of light, that's pretty much sources of light, sources of particles. It has to be producing something like that, otherwise it's kind of hard, like it's like impossible to like detect such things. So pretty much, the dark energy researchers, they have a tough job because they have to, like, they're mapping the sky and trying to figure out more details about the expansion and figuring out what dark energy is. But everything that they would consider as proper so when I say light, I mean all the wavelengths of light, not just visible light. I mean gamma rays, x-rays, whatever, infra, whatever, radio, it can be anything, any light is more than just visible light, right? Light is not just the eyes, not just the light that we can see with our eyes, but all wavelengths of light, right? So those people have to look at sources that are really, really far away, like very high redshift sources, and see like what those are doing and like what's happening with them, and measuring like how much things are moving apart and all that. Like, so it's kind of tough, like it takes time. And so we have these special telescopes and spectroscopy. So DAISY, dark energy spectroscopic instrument, it will also use spectroscopic data to do this kind of work. But ultimately we are looking for sources of light that is far, 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 far away to do astronomy with, because we're asking a question that only matters at a very large scale, which is the scale of expansion. So, it might be a while before we get more information out, because they're doing these measurements. They have to collect a lot of data, and then they'd have to analyze it and publish it and all of that stuff. and we've gotten better at measurements and observation. And so there is more and more of this kind of work happening and data coming, but it can be a while. But the interesting thing is that as far as theoretical considerations go, dark energy is over 100 years old, because the first time it was introduced and as a concept, and we realized that we need something like an anti-gravitation term, was actually with Einstein doing general relativity and having to include something called the cosmological constant in his equations to stand against gravitation. You'll have to share the paper with me, Shibargo, if you're gonna make that claim. I don't know. There could be, so someone is mentioning about the dark matter. I mean, I don't know what paper you're talking about, but it could very well be, like, you have to be careful when you read these papers, because it could very well be that somebody had a candidate for dark matter, and it's that candidate that is being constrained as a theory based on observations. So that could very well be the case. Gardening, when scientists can't explain. Well, they have to, whatever theory they do come up. So I think the problem is not that is logical or illogical. The problem is sometimes something is a theory, and it has to be proven with experiment or updated with experiment. So the theories that survive are the ones that have seen the trial and error and have gone through these iterations of measurements being made and observations being done, and they still have to kind of make sure that whatever they're saying is consistent with everything that's observed and measured. And the thing with dark energy, the thing with the expansion stuff is all, it's been measured. So, and dark matter, something, the fact of this extra matter being there, those are all measurements. Okay. So hopefully that was a helpful discussion. No to what? Dark matter is not a totally unproven concept. There is evidence of dark matter. We just don't know exactly what the particle nature of dark matter is. Okay? I'm checking my email. I think I got something. Can you please like, share, and subscribe, everybody? So someone said, I found out that almost all theories gets short. What do you mean? I will answer it in a way that I understand. No, I meant that a dark matter is just a totally unproven concept. Or falling. Let it be, it's not bothering me. So you should definitely check out my lives in the past where we have talked about the evidence of dark matter. Dark matter is a concept. So now I spent some time above. Okay, I spent some time above talking about the expansion of the universe. This is to do with dark energy. Now, coming to the concept of dark matter, it is a topic, thankfully, that is has evidence and is relevant at all other, like at all scales. Like it's even relevant in the scale of our own galaxy, which is considered pretty local in terms of, you know, the entire cosmos. And so we can certainly talk about dark matter again, but I thoroughly recommend that you go and look at our earlier lives, because we have talked about dark matter in a lot of detail. The evidence of dark matter, especially the rotation curves evidence, and we have also talked about dark matter candidates and whatnot. So certainly we can pick it up again and talk about it again, but we have in the past if you want to check it out. Gets short in explaining reality. Okay, so theories can sometimes be wrong, but more often than not, what theories actually need is sort of constraining. Like you can come up with a theory, but then when you go and do an experiment or you measure something, what you find is not necessarily, it doesn't have, it sometimes could prove the theory entirely wrong, but sometimes it just says that the theory needs to be updated. And sort of these ranges, let's say there were some numbers like, oh, we expect some particle of this kind of curve between like that the curve should have gone like this, but then the experiment finds that the curve actually goes like that, right? Or like maybe it's much more shallow. So that's what I mean by constraining a theory. So theories, especially theoretical physicists, they're valuable in the sense that you're trying to explain something, you're trying to have a mathematical explanation of some concept. But then, of course, it's a very much a back and forth between theory and experiment to come up with the final answer, if you will, or the updated answer, because it always keeps on going. Research is really never ending. And you would update the theory with what you found and make sure that at any given point, it's always consistent with every observation and measurement. So sometimes each one is still catching up with the other. But that is not to say that theories are wrong and, you know, we shouldn't consider them and so on and so forth. It's just a process. You have to think about science as an iterative process where you have to update things and to revise things and have to be flexible about learning more. But I appreciate your questions very, very much. It's been great. Thank you so much. Please do keep them coming. Please do like, share, subscribe. Please do subscribe. We will talk about this again. So I am not going to forget at all that you expressed interest in dark matter. And pretty much, if you're interested, we can talk about it more next time. So you don't have to feel like we don't hear your concerns with dark matter. We can certainly pick it up and talk about it in more detail and cover a few different evidences and whatnot, so that it's more of a grounded in evidence kind of discussion for you, since you brought up dark matter. I went on that spiel about expansion and dark energy, so I don't want to confuse people. That's dark energy. Someone asked about dark matter. We can certainly talk about it next time, okay? When will you go live again? I'm going to try to go live again tomorrow afternoon. Not tomorrow night, but tomorrow afternoonish.